right, so this is a bit of a fun one. I figure it's the second day of the conference. We've got the gala tonight. Let's have a little bit of fun. So I've had the pleasure, actually, one of my colleagues in our creative school just did a TED Talk about video games and how they actually enhance the ability to retain and process information. So if you're interested, that is Dr. Kris Alexander, who is the other lead author on this paper. And what really jumped out at me is that this really seemed like an answer to our last mile problem. Just a quick show of hands, how many people have been trying to work with contractors or facility operators or facility managers, and we show them BIM or we show them something and they go, this is too scary. And they just can't engage with it. So that's been my challenge, and I'll just get through a little bit of this. So as you can see on the screen, just to give you a sense of what you can expect from me overall, what we're trying to do is really find a way and a solution to this problem of how can we actually get our research actually adopted in real life. So I've been sharing this slide actually since I'm presenting at SIB-W78. Last time it was in Crete in 2017. It was my first time here, and I still use this quote because this is the quote that actually guides my research group. You know, I get 100,000 pieces of information that come across my desk every year. If you can tell me the 10 every day that are important, I'm going to be your champion. And the guy was true to his word. I said, okay, this is now my vision. It's my mandate. We're going to find the 10 things every day that you should care about and actually find those needles in a haystack. So we did. And then we presented that to our maintenance and our executive director of the maintenance and facility services. And he was like, well, this is really scary. We're still using paper. I'm trying to teach my team how to use tablets. So these BIM models are just way too overwhelming. There's no way. We're years, this is about 2018, 2019, it's like we're years from being able to ever even engage with the work that you've done. So I've had a full campus model of my university since 2016. And it's only now that I'm actually able to start getting them to engage. So the objective of the research that we have is to really take what we know from video games, probably the least intimidating technologies in the world. Right? Every kid just can pick up a controller and play around. My son's in the hotel room right now, probably doing exactly that. And we want to use that to develop digital twins that are more engaging for our users, they're more immersive, and they're less intimidating, but also that are a lot more just intuitive, right? We want to be able to show data in its context in a way that makes sense. So how can we do that, and how can we draw from what we know about video game design to actually make this as accessible as possible? So some of you have seen this presentation that was done by Simon Sinek. It was his big Apple thing, right? Start with why. So he was talking about how Apple talks, you know, all of these other computer companies were talking about what their product does and how they do it. And Apple would say, okay, this is why we're doing it. And this is this idea of purpose-driven game design, or as I'm saying, purpose-driven digital twin design, is we start with the why of why we're making it. Why are we making a digital twin, right? We've all got great technologies. We can make really cool digital twins, but what's the purpose? What's the point? How are people actually going to use and engage with that? Once we figure out that why, then we can figure out how to actually best implement that. So that's what I'm going to get into is there's this framework. It's the MDA framework, which is mechanics, dynamics, and aesthetics. And then the final game, the what, winds up being a lot more effective when you actually use these principles. So in order to define the user needs, we needed to actually come up with some user profiles. So we came up with 4 different sets of groups who might be interested in actually seeing the building. First, we've got people from the broader community. This might be the campus, this might be neighbors, this might be potential donors, politicians, whoever, right? And we said, okay, what do they care about? Well, they want to be able to see the building. Maybe they want to access some of our publicly available data, our space usage reports, our energy intensity, like our energy meters. Next, we're going to have visitors to the building. Well, visitors to the building might want to do the same thing as the community members, but they also want to be able to navigate, right? They need to be able to figure out, find their way around the building. Maybe they have a meeting in a lab. Maybe they're a new student and they're trying to find their way to a new classroom. Then we have facilities management personnel. These can be our own staff, or they can be contractors from outside. So they might need to actually have a path to a piece of equipment that's actually drawn for them and actually walk them through how to actually get to where they're going. Then they're going to need to be able to locate the equipment in the space, identify faults, access the current equipment data so they can actually start to run some diagnostics and say, okay, why am I here? What's the data showing? All right? And then we've got the facility managers and the engineers and the operators. And they need to do all of these, but they also want to be able to run what-if scenarios, access recommender systems, and optimization. And this is actually where this touches with a much, much larger project, where we're actually trying to create a cognitive digital twin of our university campus. So my student, Faribar, he's one of my PhD students, he's actually going to be presenting a couple of papers tomorrow on some of the automated fault detection work that we've done that will actually be integrated in here and actually show, so we can actually visualize where the faults are. I've got other students working on energy optimization so that we can actually recommend set points. So really trying to come up with something that actually addresses a lot of the issues that facilities management have. We've already mapped in like work order patterns, so where are some of the issues and the complaints that they have. So let's get into some of the elements of video game design. So from the developer standpoint, you start with the mechanics, which is basically what are the rules of the game? What are the allowances that we give people? And how is the game going to work? The dynamics is the actual physical implementation of it. So how do you actually engage actively with the game? Right? And then we have these aesthetics, which is what does it look like? The player, coming from the other side, is seeing a different side of it. They see the aesthetics first, right? When you think about a video game, you usually think about the graphics, maybe the immersive music, some of those ones that had, Paul McCartney actually doing the soundtrack. Spent a lot of money on this, like the whole experience, the whole user experience of the game. Behind that are, how do you experience playing through? How can you navigate? What can you do? How do you interact? And then the mechanics is really that layer that's hidden underneath, which is what are the rules that govern the universe that you're managing and you're actually going through. So if we talk about like our digital twin mechanics, the first one is player autonomy, right? And these are some fundamental questions that we have. Can our user fly? Right? Are they limited by gravity? Our facility managers want to be able to teleport and instantly go to the location of interest. They want to be able to instantly go where they want. They want to be able to pass through walls, see through walls, have x-ray vision, etc. But for wayfinding, the ability to fly and pass through walls is not going to give you a feasible thing. If I tell you to go upstairs by going up through the ceiling right now, it's not very helpful. You actually have to be navigated to the stairway and actually have those constraints. So certain player modes are going to require different levels of autonomy. Affordances are the things that we put into the game that actually allow you to do things. So for example, if you look at the Super Mario, it's the ladders, right? A ladder allows somebody who's ordinarily governed by gravity to ascend vertically. Or similarly, same with staircases, right? And then the signifiers are actually how we show that that's there. So for example, this is a door that actually shows that the door can be opened, right? So it's lit up, it tells you that this is an element that you can interact with. So we had to think about not just what the rules were, but how to actually enable the user to actually navigate those rules, and then how to tell them in an intuitive way that they're there. So when we're defining the digital twin mechanics, we actually had to come up with these modes. So the first mode is the see it mode. That's just, we're not assuming that you want to actually find your way around the building. And this could be anybody using it, so you can teleport to your location of interest. So maybe you want to see what's on the 9th floor. And then maybe you want to access a publicly available dashboard. The next one could be the wayfinding mode. I need to find my way to a certain thing. So this would be the 3 groups that we would expect to be on campus. So anybody visiting, any of our trades, any of our staff. All right? They're going to want to do things like climb stairs, because they're going to need to actually find those paths. The investigate it mode, you have all of these abilities you can navigate, you can teleport directly, you can pass up and down, you can use the wayfinding if you want, you can see through walls, you can pass through walls, right? So you have unlimited freedom of movement, but you can also see all of the inner workings of the building. And this would be primarily for our facility management personnel, right? So really thinking about who's going to be using it and why and what they're looking to get out of this. And then finally, we have the operated mode, and this is the one that we're in the process of actually implementing. That doesn't just have the visualization and the ability to query data, but has the ability to change the data. So right now, just full disclosure, facilities management does not let my research group actually change the controls in the building in real time. But they have agreed to let us run some simulations and to actually run some experiments at night to actually increase the data domain, so that when we're training our algorithms, we can actually have recommender systems saying, you know what, you can save about 10% off of your chiller if you increase your set point temperature from 7 degrees to 8.5 for the next 6 hours, given the weather, and this is the simulation that shows that this is right. So the ability to run these what-if scenarios and really start thinking about how we can reduce energy in real time and bring online optimization into it, which is probably actually more my core research. This is just the fun way of actually presenting it. So now that we've defined the mechanics of how the digital twin works, let's think about the dynamics of it. So you need to be able to find your way through. We need to figure out how to not overwhelm a system. So this is designed to actually run within a window, just a little web browser. So you can actually access this on a tablet. You can access this on a little computer. You can run it on a PlayStation. So we needed to not load the entire system. Right, I've got 14,000 building automation points live streaming into this building. Every single piece of mechanical equipment is actually developed. So there's a huge amount there. So we don't want you to be able to, we don't want to load anything you can't see. Just like if you play, say, a Nintendo game, it only loads the part of the world that you're in. Otherwise, it would overwhelm the system. So we developed these blueprints using the Unreal Engine that actually allows us to replicate it. So we have an automated system to bring any new building in. So I've done work that's been presented at previous conferences on creating lean FM-enabled BIMs that are suitable for this sort of facilities management work. It's just your walls, your rooms, and your major mechanical equipment, and then actually being able to map that equipment in to actually query into the database. And there's the cognitive digital twin paper that's referenced in this, actually gives a little bit more background on how all of that works. So let's look at this. This is our see it mode. So this is just, as I say, you can just jump straight to a level. This is what we call our mid-resolution version. So you have different ways of looking at it. You can navigate, you can pan in, and you can actually look, and you can even query some of the data. So this can actually give you some sense of what's actually happening. All right, so this is a little bit souped up from the see it mode in terms of what you can do. The next one is a more rigorous investigative mode. And this actually allows you to look. Actually, I think I might have put the same in twice. Yeah, I did. All right, so this was the investigation mode where you can actually see we're querying the data in real time. So we do have a federated data lake that actually allows you to say which is this equipment, what's the point, access the time stream data, and then display it. The next one we have is our navigate it mode. And this is where you can actually go through. And say you're a facility manager or you're a contractor, you know that you need to go to room 306. So you've got the choice of taking the stairs or you can take the elevator. Here, it's just 2 floors up, let's take the stairs, right? So actually coming through, we wanted to give something that made it easy enough for our facilities managers to actually see where they're going. And we outline the door to the room that they're actually accessing in red, and you've got a sense. Now say that they wanted to go somewhere else, and then you can actually move over. And this time, we're going up to the 8th floor. There's no point in taking the stairs, so we're actually going to take the elevator to go up. And this allows us to go all the way through. All right. And again, once again, it actually goes through and actually allows us to see where we're going through. Now, the last one is what if you're actually trying to find a piece of equipment? And this is where the back end actually makes a lot of sense. So we can query this BTU number 50. It will actually query, we've got a graph database behind the scenes, tells us what room that is in. It will actually then navigate you to that room. So it's got a Pathfinder algorithm that's actually baked into it, and now you can actually address it. You can turn off the ceiling, so you actually know exactly where you're looking. And this is actually engaging with the construction level BIM. And again, this is another view of this investigative mode. This is now looking at a little bit more of a rigorous inquiry into some of the data. So you can actually look at the historical data. We've got the blue, the light blue is actually the unit we're looking at. Now you can actually select 2 additional units, look at them side by side, and actually see if we're seeing different things. So this is Q. Q is the air quality, so the CO2 measurements. Now we're going to jump into the mechanical space. So you can actually get a sense of what kind of equipment we have, and you can see all of the most recent change of value data for all of that equipment. So if you're a HVAC engineer, you want to see what the equipment is doing right now, you can see this. And if you actually want to run trends, you can do that as well. Next, we have to define the aesthetics. So there's a few common games. So you can actually set a lot of different things in the user interface for just the way that the aesthetics are, right? How are you going to present the data? What color schemes are you going to use? What's going to be the graphical feel for it. And then if you think about the user experience, what's the mood or the atmosphere that you're looking at? How easy is it to use? And what's the intuitive data context? So we're really trying to take the best of human-machine interaction and dashboard development and actually bring those in. And I'll give you a really quick sense of this. This is my last animation for you. And this is actually looking at color coding of the equipment. So the light blues are things that are too cold, the dark blue are too low, and going up to red is too high. So here you can see the discharge air temperatures are too low in those two dark blue areas. Now we're going to go up, or we're going to go down into the basement. And we're actually going to look, this was actually a query that one of our facilities managers had, is, well, could you just show me the location or how open our cooling coils are? So I can see if they're all red, I know I need to actually decrease my chilled water temperature. If they're all blue, I can actually afford to increase it. And because we had all of the access to all of the time series data, we were actually able to do that on the fly, which we were pretty happy with. So we do have a conceptual framework. Whoa, sorry about that. Macs don't like me either. So just really quickly, this is detailed a lot more in the paper. It's basically the fundamental questions that you want to ask at each stage as you actually apply these principles to develop a better digital twin. So I'll leave that to you to read on your own. So the findings. We did a demo about a month ago. And as they said, Ken, you've shown us this too much. I said, wait a sec, you can navigate it with a PlayStation controller. They're like, okay, cool. So we had 4 people on there. Their first question was, can we play with this for a month? So facilities management is now playing with the equipment right now. They're trying to play with this demo environment. They found it really intuitive, and like I said, they were immediately able to see the value of it. So we've developed this demo environment. It's being deployed. We're doing the full field studies, and we're going to let the facilities managers actually develop the new use cases, and we use kind of a lean and agile approach for fleshing this out. So we find the next use case, we figure out the minimum information requirements to implement it, and then we implement it. We're trying to take, as you probably noticed, there's a difference between the navigated video that I showed you and the investigative video. So we're bringing in all of the investigation level blueprint functionality into that higher resolution version to actually give the photorealistic version. And we're also in the process of developing our tutorials. We're going to be replicating it. And scientifically, the most interesting one is we're actually starting to bring in this online interface with our AIs. So when our algorithms detect a fault, they're now automatically opening up a ticket on the system with a screenshot of the data saying, we found a fault, this is the data, we think it's this. You might want to investigate it. So it's much more of a recommender. Just a few references, and just to acknowledge this research has been funded. This has been a 5-year research project. We're in the 4th year. So, and FuseForward, and of course our university have been incredible partners for that. And I'm definitely at time.